Hello folks, today we're going to be talking about combining functions and a couple of fancier function applications. As you guys know, you can definitely do basic operations with functions, add, subtract, multiply, and divide. You should be comfortable with the two different styles of notation, whether you have your f of x and g of x separate, or whether you lump them together into one style. Different textbooks and different sources have different preferences on how they do this, so I'm presenting both just so you're comfortable seeing either. I personally think the right-hand side makes a little bit more sense, but different textbooks vary and WebAssign might vary, so I want you to be comfortable with both. So we got our four basic operations. Well, we also have this composition function. Composition actually allows us to nest one function inside of the other function. In this left notation, the composition is this little open circle. In the right notation, we actually put g of x inside f of x. So for example, if we've got f of x equals x squared and g of x equals x minus 3, we can actually do fog, or f open circle of g, which is going to take the g function and put it into the f function. Our g function is x minus 3, so that means the same thing as saying f of x minus 3. Doing a straight trade g of x for x minus 3. We know how to evaluate f of x minus 3. That's just plugging x minus 3 in for the x. Don't confuse the two x's. They are different. They both are generic stand-ins, but they are different x's. For the second part, when they ask us to go GOF, that means that we're plugging the f function into the g function. When we plug the f function into the g function, that's like taking g of x squared. So the x inside the g is going to get replaced with x squared. And so we get x squared minus 3. Down the bottom, they ask us to do f of g of 5. Now, if you want, you can redo the whole problem, figure out what g of 5 is as a number, take that number and plug it into f, like a domino, a chain of events. Or you could say that you already know what f of g is defined as, this x minus 3 squared, and we can just plug 5 into that, because we've already done all the algebra to get ourselves ready. 5 minus 3 is 2, 2 squared is 4, and then they ask us to go GOF. Be careful you pick the right one. This is showing us that order of operations matters, meaning that g of f is a different equation than f of g. So we get ourselves 7 squared minus 3, 49 minus 3 is 46. Next example, we've got two different functions, and we're just asked to do a couple of different compositions. We're going to plug the g into the f. If you don't like this notation as much, and you prefer to actually read it as f parentheses g, you can always just sneak parentheses into the problem and make it look that way, if that's a little bit more comfortable. So we're going to plug the g into the f, square root of 2 minus x. Then we're going to plug the f into the g, which is square root into there. We can actually plug f into f, so we're going to plug the square root of x into the square root of x. And then we're going to plug the g in the g, square root of 2 minus square root of 2 minus x. Now this is going to take the same idea that we've been playing around with and combine the things that we were just talking about in the last lesson. So we're going to have to use graphs to help us out. This f plus g of 2 is basically asking us what is f of 2 plus g of 2. To find f of 2, I have to look on that f squiggle down the bottom at 2, and I have to recognize that f of 2 is going to be the height at that time, which is 3. G of 2, I'm going to use the exact same strategy off the blue squiggle to find g of 2 as, what's that, 5? So f plus g of 2 is 3 plus 5, or 8. Now they were really nice to us, and they stayed at 2 on all these, so I can reuse that 3 and 5 a bunch of times. This is taking the f value, which was 3, minus the g value, which is 5. 3 minus 5 is negative 2. If they had gone to a new coordinate, I would just have to use the graph to be able to get some new values. Perfectly happy leaving it as 3/5. If you really want to make it a decimal, you can. Oftentimes you'll see worksheets or tests even use the same equations for a couple different problems. This is just much easier to enter into a computer or word processing program, so it's convenient for the test maker. F of 2, we just plug 2 into the f equation. G of 3, we plug 3 into the g equation. Those don't really combine to be any prettier, so we can just say square root of 2 minus 7. For this one, I'm going to figure out what h of 6 is first. Come to the h equation, 6 divided by 3 is 2. And then I'm going to take that 2 and I'm going to plug it into the f equation. Again, order matters. I'm plugging into the right equation first and then into the left. F of 2 is just the square root of 2, and I got my answer. For this one, I'm going to follow the number out. Figure out what h of 18 is first. 18 divided by 3 is 6. The other two letters are still there. Then I take g of 6. G of 6 is going to be, 6 minus 10 is going to be negative 4. So I get f of negative 4. And then f of negative 4 is the square root of negative 4. Now, I would either accept that as 2i, or if you want to say does not exist, I'd be fine with that too, because you can't have the square root of a negative number. We'll talk more about i's later in the course. F minus h of 6 is essentially f of 6 minus h of 6. F of 6 is square root. H is going to be 2. And that's just my answer. This one's a little bit more of a head scratcher. This is the exact same strategy, but we're working backwards. P.S. I should also apologize for the speed. I'm trying to get this all done in under 15 minutes so I can use my free version of the software. This is working backwards. The idea here is that they're giving you the answer of this statement made up of all these different functions, and they're asking you to put it together. What I'd suggest you do is think about how you would evaluate this with a number. So if I asked you to do k of 5, the first thing you would do is do your 5 minus 4 to be able to get 1. The next thing you would do is take that 1 and you would cube it. And then the last thing you do is you'd multiply that answer by 2 to be able to get a solution of 2. There's 3 separate steps of this problem. First we subtract the 4, then we cube, and then we double. We look at the functions up top and we see the first option of subtract by 4 is h of x. So that's our innermost level of this problem. After we subtract by 4, we then cube it. Cubing is the f function. So I'm going to take h of x and put it into f. After I subtract the 4, I'm going to take that answer and cube it. Lastly, we double it, which is the j function. And that creates my order. So my k of x equals that grouping of letters. Over here, it's some of the same functions, just different order. The first thing I would do is subtract 4, so it's my innermost. After I subtract 4, I would cube it, just like last time. So I'm still going to have my f. This time, instead of doubling it, I want to square root it, which is my g. Here we just see a couple of examples. Play around with your different operations. I want to plug g into f. G is the square root. So for part A, I'm doing 1 plus the square root of x minus 1 squared. But square rooting of squared just cancels each other out. And so I'm going to get 1 plus x minus 1. The 1 and 1 cancel each other out, and I'm just going to get regular old x. Part B, I'm going to plug my f function into the g, which is square root of 1 plus x squared minus 1. 1 minus 1 cancel each other out, so I've got the square root of x squared, which is just going to be x. If I want to get technical, it should be the absolute value of x. Then I go to C. Now I already found out that f of g in part A is just x. So if I plug 2 into this equation, I'm just going to get 2 right back out. And that's my answer. If you don't believe that, feel free to actually run through the problem. F of f is going to cost me to actually do it, because I don't know what that is off the top of my head. That's 1 plus parentheses 1 plus x squared squared. Now because x is 2, 2 squared is 4, plus 1 is 5, squared is 25, plus 1 is 26. E is getting a little wilder. For E, I'm going to do f of g of f of x, or f of g of f of x. I'm writing it in this order because g of f I already did before in part B. In part B, I realized that g of f was just regular old x. So this is a really complicated way of just saying regular f of x. Regular f of x is 1 plus x squared, and that's my answer. For f, I'm going to take g of f of g. f of g, we already found out in part A, is really just x. So this is g of x. G of x is just square root of x minus 1. Now there's much longer ways to do these problems, but what you really want to do is just run through and make sure you've got all your bases covered. This is a really tricky problem by sneaking in an extra letter, t. We know that f of x equals that equation, and we know that f of t plus 1 equals 0. There's two different ways to approach this problem. You can either figure out what f of t plus 1 is, which is t plus 1 squared minus 9 times t plus 1 minus 10, and set that equal to 0, and then solve for t. Another way to solve this problem is to find the x values that make the original problem equal 0, and set those x values equal to t plus 1. It's a much more elegant way of doing the problem, but it's harder to dream up right there on the spot. For this one, remember you cannot distribute a squared across, so you want to think about it as t plus 1 times t plus 1. So 9t minus 9 minus 10. And what do I got? I got a t squared minus 7t minus 18. So maybe I'm going to have a t minus 9 and a t plus 2. So my t is either going to equal 9 or negative 2. So because I'm looking for values of t, I know I'm done. If I went with the other strategy, I'd have to find out what x is first, and then set x equal to t plus 1 to make sure that I'm answering in terms of t. Hopefully this makes a little bit of sense. The beauty of it being on a video is you can go back and rewatch any sections that you feel a little bit fuzzy on, and we can talk more when I see you next in class. Have a good one.